Hi, and welcome to another Contemplative Friday. We took last week off, but we're back, and today we're going to be visualizing a structure with the center atom and 5 charge groups around it. But before we get to that, as always, let's find some time or create some space here to relax a little bit. Find ourselves in a nice straight sitting position, or if you're sitting on the floor, maybe your legs crossed. Just make yourself comfortable. Nice tall back. Allow for easy breathing. Maybe relax your shoulders. Rotate your neck a little bit just to loosen up. And if you feel comfortable doing so at this point, I invite you to close your eyes. And we'll begin with some long, slow, deep breaths to the count of 4 or 5. And exhale to the count of 4 or 5. And another long, slow, deep breath in. Long, slow exhale out. And another long, slow, deep breath in. Long, slow exhale out. And one more long, slow, deep breath in. And a long, slow, deep breath out, exhaling all the air. And now we'll just let our breath return to normal, not control it. Just let the body do it for us. And at this point, we'll try to empty our mind of thoughts and concerns about the past or the future and just focus on the present and focus on where it is we feel the breath. You might feel it at the base of your nose as cool air comes in and warm air goes out. Or maybe you feel it in the rise and fall of your belly. But we'll just focus on that sensation. As thoughts come into your mind, note them, and then gently invite your attention back to your breath. And take one more minute of quiet to try to release the cares of the day, of the week. Give ourselves a moment to clear our heads, prepare to visualize molecules, but for right now, just return your attention to the breath. And in the next few minutes, we're going to build a molecule that has trigonal bipyramidal geometry, one atom at a time. So we'll start by imagining just a single atom, recalling that an atom has a nucleus of positive charge, surrounded by electrons in p and s and d orbitals. So just picture a single atom. And now we're going to bond 3 more atoms to that central atom. So imagine first 1 more nucleus in addition to the center nucleus. And imagine electrons overlapping between the 2 nuclei. 2 electrons sharing space around those 2 nuclei, creating a covalent bond. Now link a second nucleus to the center atom. Again, shared electrons between the central nucleus and the new nucleus. And now we'll add a third nucleus, again with electrons overlapping, being shared between the new nucleus and the central nucleus. And if we picture that set of nuclei, we get something that looks a little bit like the peace symbol. Each bond between the central atom and the peripheral nucleus, they'd all be separated by 120 degrees. So picture that. And rotate that around in your mind. Let it tumble, let it spin. Try to get all the nuclei in one plane in your mind. Spin it, maybe like the spin of the Earth, that central atom being at the center of the Earth, and the 3 other atoms all laying on the equator, 120 degrees apart on the equator. You can rotate that in your mind. Or let it start tumbling about in space. Imagine the Earth just kind of off kilter and tumbling around. So in this very center, if we connect the 3 equatorial nuclei, we would have a triangle. Now, in the North Pole position, we're going to attach another nucleus to the central atom by sharing 2 electrons. And in the South Pole position, we're going to do the same thing. Another nucleus sharing electrons with the central nucleus. So now we have 5 bonds to that central nucleus. Starting at the North Pole position, bring your attention to that North Pole nucleus and drop down to the center nucleus and then out to one of the equatorial nuclei. What bond angle is that? That's a 90-degree angle from North Pole to equator. In your mind, follow the North Pole position down to the central atom, out to all three equatorial nuclei. All three are 90 degrees. Starting at the South Pole and its nucleus, move your attention up to the center and then out to the equator. Another 90 degrees. So within this geometry, North Pole to the equatorial positions is 90 degrees, South Pole to the equatorial positions is 90 degrees. Bond angles between the nuclei in the equator are 120 degrees. Imagine holding this molecule at the North Pole and the South Pole. Picture maybe your left hand on the North Pole, your right hand on the South Pole, and then spinning it, just like the Earth spins, or just like a fidget spinner. The three nuclei at the equator spinning around. And then imagine releasing it from your hands and letting it just tumble through space. We can picture the trigonal bipyramidal structure by imagining that triangular base in the equator and then building sides from the equator up to the North Pole and down to the South Pole. Those would also be triangles. So we'd have three triangles on the top faces, three triangles on the bottom faces. So we'd have a pyramid on top and an inverted pyramid on the bottom. So two triangles with triangular bases, trigonal bipyramidal. Lastly, we'll return our attention to having a center nucleus, 5 nuclei around it. But now remove one of the equatorial position atoms. Just pull it away in your mind. Break that bond. And replace it with the lone pair of electrons. The lone pair is no longer tethered to an atom in the equatorial position. Those electrons expand and take up a little more space in the equator. So because they take up more space, they create repulsions with the electrons being shared between the center atom and the two other equatorial atoms. So those atoms try to get out of the way a little bit and they squeeze together a little bit. They're no longer 120 degrees apart. Maybe they're only 118 or 117 degrees apart because that big old lone pair has taken up more space in the equator. And the North Pole and the South Pole bonds would try to get out of the way too, so they'd tilt back a little bit. So North Pole to center atom to lone pair would actually have a little tilt, a little greater than 90 degrees. South Pole up to the center, over to that equatorial position, also a little greater than 90. So North Pole down to South Pole has a little kink in it now, a little less than 180. It's not linear anymore, not perfectly linear. And if we had a second lone pair in such a geometry, it too would go in the equator. So remove the second atom and put on a lone pair. And if we have 3 lone pairs and 2 atoms, the third also goes in the equatorial position. So now we have an atom in the North Pole, a central atom, and an atom in the South Pole, with 3 lone pairs of electrons in the equator. The atoms would be in a linear arrangement. Xenon difluoride is an example of such a molecule. So go ahead and spin that molecule around in your mind. Look at the lone pairs, look at the fluoride, look at the xenon. Let it move around, give it some dynamics. And how wonderful it is that we know about the shapes of molecules and then how those shapes dictate chemical reactions and where electrons are and therefore what they're going to react with and how quickly they're going to react. So by learning about these shapes, we're setting up to learn about all sorts of wonderful chemistry. And we could do the same visualization with other geometries. And how cool the shapes are. And if we look for them in our daily lives, we'll see exactly the same shapes. The Egyptians built pyramids thousands of years ago. So we see these patterns repeating in nature. It's pretty neat. So at this point, we'll take a long, slow, deep breath in. Long, slow exhale out. Long, slow, deep breath in. Long, slow exhale out. We'll just take one more minute here at the end of our week to be quiet, to calm our minds, to be present, to be grateful for learning. I'm grateful for the opportunity to teach and to learn alongside of you. And as you're ready, you might begin to wiggle your toes, wiggle your fingers, shrug your shoulders, slowly open your eyes, return to the day. I hope you have a great Friday. I hope you have a great weekend. I look forward to seeing you on Monday, and I hope you continue to work on visualizing molecules, building them with the model kits, modeling them in WebMO, all wonderful things that we get to explore. Have a great day and a great weekend.